Hello. Today I'm going to be showing you what the formulas are for both the area of a parallelogram and a trapezoid. I will also discuss an example of each of them as well. I am not going to explain where the formula comes from. That can be found in another lesson. So let's just take a look at these two shapes here. I have discussed in other videos that the parallelogram is a special type of quadrilateral that is in the same family as the rectangle and a square, which I discussed the area and the perimeter of each of those in another video, the area of a rectangle being the length times the width, and the perimeter being twice the length times twice the width. And then the area of a square being exactly the same. The only difference is that the lengths and the width are the same. So it's just side times side length times side length, or side length squared. And the perimeter, this should be a plus sign. And the perimeter is, those four side lengths added together. So it's just 4 times whatever the side length is. So those are ones that I've discussed before. Now the area of a parallelogram has to be found the same way as these, since they are in the same family, right? And essentially you can think of a parallelogram as a rectangle. If I, took this and chopped that off. So if I took that, see if it'll do it, and chopped it off and I stuck it over here, right? You would see that really what you have here, and I'll highlight it, when I chopped it off and moved it, is, well, you have a rectangle highlighted there in yellow. So really the parallelogram is a form of a rectangle. It's just the rectangle has more properties to it, like the idea that all 4 sides are right angles, for example. So the way that we find the area of a parallelogram is going to be the same way. It's going to be a length and a width, but that width that we have here, this width right here, is really what they like to call that width the height of the parallelogram. Okay, and this obviously here, that's going to be your length, which would be equivalent to this length down here, right? But in a parallelogram, they don't call it the length. They like to call that length, sort of running out of space here, they like to call that length, they like to call it the base. So whenever they're talking about the area of a parallelogram, they like to use a base and a height versus a length and a width, but they really are the same thing. So let me show you that in a prettier picture over here. So if we look at the area of a parallelogram, so here's a good picture of a parallelogram. In this picture, you can see that both of these lengths are labeled as B, because in a parallelogram, opposite sides are not only parallel, but they are congruent, right? So they're the same length. It's sort of like a tilted rectangle, if you can think of it that way. And so remember, I'd show you over here that this was my width and this was like your length, but they like to use base and height. So the height of a parallelogram, the way you find that is you should just draw a straight perpendicular line from the one base to the next. So the base could technically be, the height could basically be here, which would be the same as this height here, right? So that's how you find the height. And oftentimes it'll be labeled there with a dotted line like you see here. And here is your base, right? Which is similar to our length. So the H standing for the height, and B standing for the length of what they call the base. But again, remember that the height is similar to the width, and the base is similar to the length. Okay, so that shows us that the area of a parallelogram here is not going to be length times width, or I mean, you could think of it that way, as this is the length and this is the width, but you'll often see it represented as base times height, which, remember, if we think about it, is really just length times width. They just use different letters there, right? So this is your area of a parallelogram, okay? So that's your area of a parallelogram. Now, if you wanted to find the perimeter of the parallelogram, that would be a little bit different, but still the perimeter is the idea that you would have to find the length of all four sides. And you can see that if you look at this picture down below, they don't give you the length of all four sides. Like, they didn't give you the length of this side, which would be congruent to this side. They didn't give you those lengths. You would have to somehow find the length of those using other mathematics, but we're not going to be discussing that today. The true concept that you want to get by here is being able to use this area of a parallelogram formula, being able to recognize the length and the width, which we are now calling base and height when dealing with a parallelogram. So doing this example here, this length is 12.9 inches. They're talking about the whole entire base length being that, not just this portion here, right? So that's this length is 12.9, so that means this length is 12.9 as well. That's going to be representing your base, or your value of B. Remember that the height is always the length from that you get from drawing a perpendicular line from one base to the next. So we can see here that in this problem, that if we draw a line from one base to the next, that is the 7.1 length that you see here, and that's going to be our height. So when you go to do the area of a parallelogram, it's just base times height. So in this sense, in this problem, it's going to be 12.9 times 7.1. Okay, so 12.9 times 7.1, you'd have to get your calculator out for that. I have mine right here. 12.9 times 7.1, and you get 91.59. So I'm going to keep it to 2 decimals to the 100th place. That's a really bad parallelogram. And it is 91.59. Remember, with area, you are talking about inches times inches. And just like x times x would be x squared, inches times inches would be inches squared. So that would be your area of your parallelogram. So make sure that if units are included in your problem, that you include the units of measure correctly in your answer. Okay? So the next thing that we're going to look at is the area of a trapezoid. Now, the area of a trapezoid is a little bit different than a parallelogram, because in a trapezoid, the bases, or the lengths, are not the same. You have two different lengths. They're not congruent. And in a trapezoid, the other sides are possibly not congruent either, depending on what type of trapezoid you have. What is similar is that they still use this idea of B standing for base and H standing for height, and the way that you find the height is by drawing a perpendicular line from one base to the next. So that's how you find the height. Okay, so the area of a trapezoid be 1/2 times the height times the sum of the two bases. And if you want to know where that formula comes from, again, that's a time for a different lesson. This lesson is particularly just what the formula is and how can we use it. Okay, and being able to recognize what is the height and what is the base, what are the two bases. Now, it does not matter which base is base 1 and which one is base 2. This could also be base 2 and this could down here could be base 1. It does not matter. Okay, so those are interchangeable because when you're adding, the order of which you add does not matter. Okay, let's talk about this example down here. We're going to use this formula on this example. Okay, so I'm going to move the formula down here so that we can see it as we go through this example. Okay, now they don't give you a picture, but you can always draw a picture if you want to. It doesn't need to be drawn to scale. It can just be a, shaky picture like you see mine. And we have in this, they say it is a trapezoid. That's important to know. It says the base measures 23 kilometers and 29 kilometers. So one of the bases is 23, one of the bases is 29. It then tells us that the area, so I'll put the area inside, is 390. And then it says find the height of the trapezoid. Now, what's unique about this problem is they don't give you the height. Remember that the height is the length when you draw a perpendicular line from one base to the other. This is your height. So that is what we were trying to find. So we can still use our formula. Can't draw a trapezoid today. Area of a trapezoid, we can still use 1/2 times h times b1 plus b2, right? So then on this problem, what I'm going to do is I'm going to plug in everything that I know. What I know in this problem is I know the area, I know the length of the first base, and the length of the second base. So I'm going to plug all of those values in. So I get 390 equals 1/2 times h, because I don't know h, times 23 plus 29. And you can see the only variable we have left in the problem is h. So what we can now do for that is we can solve for h, taking it one step at a time. The first thing that I'm going to do is I'm going to simplify anything that I can simplify. So using order of operations, I know that I can simplify by adding what's inside the parentheses. So inside the parentheses, I have 23 plus 29, which is 52. Okay. The other thing that you can simplify here is you can, since this is 1/2 times h times 52, it's really what that is. The order in which you multiply doesn't matter. So I can go ahead and multiply the 1/2 with the 52 before I solve for h. 1/2 times 52 is just 52 over 2, right? So that gives me, if you can't do 52 divided by 2, go to your calculator, but it's just 26. So I get 26h as my, not my answer, but as my value for my next step. And then the only thing you have left to do is divide both sides by 26. 390 divided by 26 is going to be 15. So we know that the height is 15. The last thing that you have to do is give that a unit of measure. Okay, so again, a height would just be kilometers. That's what they said. The other lengths were kilometers. So the height is just another length incorporated in this trapezoid. So my height is going to be 15 kilometers. And so that is your final answer. If you like this video, don't forget to hit like and subscribe to my channel, and good luck with your practice on this.